We are continuing our study of function analysis, and today we're going to take a look at what is called the second derivative test. We have the first derivative test. The first derivative test says that f has a relative minimum when f prime changes from negative to positive. That makes sense because if f prime is negative, we're decreasing. When f prime is positive, we're increasing. So that would make this little relative minimum. F has a relative maximum where f prime changes from positive to negative. So if f prime is positive, we're increasing. If f prime is negative, we're decreasing. That would make a location of a relative maximum. The second derivative test is going to be another test used to find a relative min or a relative max. It's another test. It's an option that you can use to find a relative min and a relative max. It is an option that must be used on some types of problems where we're not given enough information to use the first derivative test. But the second derivative test does exactly what the first derivative test does. It finds the location of a relative min or a relative max. Let's consider this graph of a relative max. Okay, we know that the slope of the tangent line changes from positive to negative at a relative maximum, but how else can we describe what is happening? What is the concavity? What's the concavity of this interval? Well, the concavity here, it looks like a frown, so this is concave down, right? The concavity of a relative maximum is concave down. Okay? If a curve is concave down, must the curve have a relative maximum? If a curve is concave down, does a curve have to have a relative maximum? This one, this concave down curve, definitely has a relative max. But I could draw a concave down curve like the graph of natural log of x. Natural log of x, this is its graph. It is concave down forever. Does it have a relative max? No. Just because a curve is concave down does not mean we have a relative max. Okay, consider the graph of a relative minimum. We know that the slope of the tangent line changes from negative to positive at a relative minimum, but what about the concavity? Well, in a relative minimum, we do have concave up. It's a concave up section. So concave upward. If a curve is concave up, must the curve have a relative minimum? Well, similar to that natural log, that makes me think of e to the x. E to the x's graph does this. It's always concave up, but it has no relative minimum. So absolutely not. It doesn't have to. But if we do have a relative min, we can have concave upward. We can be concave upward. Okay. The second derivative test says if f double prime is negative, if f double prime is negative, that would be this case. F double prime is negative and f prime is 0. So f double prime is negative, so we're concave down, and we have a 0 slope. A 0 sloped tangent line. Then f has a relative max. Okay, notice that on this curve of natural log x, there is no section where the slope is 0. There's no section that this is satisfied. So the second derivative test says, yes, it's another way to find the relative max, but two things have to be true. The first derivative has to be 0, The second derivative has to be negative. Okay? Similarly, if f double prime is concave, if f double prime is positive, so f is concave up, and f prime is 0, so f has a 0 slope, then f must have a relative minimum at that point. Okay, so the second derivative test makes sense visually, and that is the test. Two things have to be true. Both f double prime is less than 0 and f prime is 0. Okay? In order to use this as a justification, both have to be satisfied. All right? Okay, let's do a couple of examples. We're given that g is twice differentiable. G of 4 is -3. That's simply a point. G prime of 4 is 0. So the slope of the tangent line is 0 when x is 4. Okay? And f double prime of 4 is 2. I really don't care about the value, I care about the sign. 2 is positive. So they're telling me that g double prime at 4 is positive. They're telling me g double prime of 4 is positive, g prime of 4 is 0. So g double prime is positive means we're concave up. G prime is 0 means we have a 0 slope. That when x is 4, we must have a relative minimum. So we're going to choose that answer. Okay? So this is a question that we could not use the first derivative test on. We have to use the second derivative test. Number 2. Let f be a twice differentiable function. Selected values of f and f double prime are shown in the table. Which of the following must be true? All right. Okay, and they talk about f has a relative max at -3, f has a relative min at 2, relative max at 10, relative min at 6. So we're using this table of values. Okay? So I am in a table of values like this. Notice this too. They're giving me just random selected values of x. -7, -3, 2, 6, 10. We have no idea what's happening between these x values. Who knows what variety of things the curve could be doing between these x values. All we know are these f primes and f double primes exactly at these x values. Okay? That's important because that means we cannot use the first derivative test. We are not going to be looking for where f prime changes signs because we don't know. Here you might think, oh, f prime was positive here, then 0, then negative, so we have to have a relative max. No, we do not, because we have no idea what's happening between here. Maybe at -6, f prime is -10, right? We don't know. We have no idea. So we cannot use the first derivative test. We have to use the second derivative test. We're looking for where f prime is 0, and at that location we're looking for f double prime. Here f double prime is positive. So that means when x is -3, we are concave up and have a slope of 0. That's a relative min, not a relative max. Let's look at B. Okay, here we're looking at 10. Well, at 10, f prime is -3. I don't even have to look any further. There is no way that could be a relative min or max. Okay, when x is 2. When x is 2, f prime is -1. No way that can be a relative min or a relative max. I know my answer has to be D. I've narrowed it down, but let's verify that. When x is 6, sure enough, f prime is 0, f double prime is positive, concave up, slope of 0, that has to be a relative min, and that's what they said here. So the answer is D. So that is the second derivative test.